Hi, this video is about power transmission. Often you see the shaft here, AB, is often used to transmit power. So for example, here AB is connected to a motor. So the motor provides power here. So shaft AB is gonna rotate at some angular velocity omega. And also its AB shaft is gonna have a torque applied to it due to this motor. So we're going to figure out what's going to be the power transmission. What's the power? So before we introduce this new formula, I want you to think about the linear translation. When you just have a linear translation, how do we calculate the power? The power, remember, is energy divided by time, right? Work over time. And we also know work is force times distance and then divided by time. And what's distance divided by time? That's going to be velocity. So in the linear world, the power is going to be your force times velocity. Then, however, here is going to be rotation. So in rotation, but we can use this formula to look at the counterpart for rotation. So same power, what will be the counterpart for force in rotational world? That's going to be torque, right? That's going to be T, or we call torque or moment. And what's going to be the counterpart for velocity? That's going to be angular velocity. So here, that's our new formula for power transmission. So power is equal to torque times angular velocity. And we can look at the unit. So power we know it's going to be watt, right? Watt is basically joule per second, energy per time. And then look at the right hand. The torque is Newton times moment of arm, which is the distance. And then we're going to times omega. What's omega? Let's do a quick review of omega. Omega is angular velocity. So that tells us how much, for example, I'm going from this position to go over the arc and going to this position. And that travels angle delta theta. So omega is how much angle it traveled per time. And however, this angle is used radians. So in other words, omega is going to have a unit of radians per second. All right, now let's take a look then. Newton meter is going to be force times distance, that's joule. Then joules per second and times radians. Radians is like no unit. So joule per second, that gives us a unit of watt. So the dimension-wise, this formula is satisfied. P equals torque times omega. Okay, so another thing I want to expand on is this angular velocity, omega. We know omega is radians per second. We often see in some other expression of omega, we use, for example, frequency of rotation. Frequency of shaft's rotation. Okay, so if we use hertz, we use hertz. Hertz is frequency, and we use F as our symbol. Hertz means like how many cycle per second, right? Like for example, you put it on a radio station, like 94.3. That means there are 94.3 cycles per second. That's how many revolutions per second. Then how is that related to our omega? So if I have frequency that's in hertz, that's how many cycles. So each cycle is going to be how many radians? We know one cycle is going to be 2 pi. So we're going to times 2 pi. That gives us how many radians? And then it's per second, right? So that means here we got an expression to relate our omega to frequency, because omega again is radians per second, and the frequency is how many hertz. That means how many number of cycle per second. And then we know each cycle is going to be 2 pi seconds. So in knowing that, let's cancel out. And then here, don't forget that's f. So that's omega is going to be equal to 2 pi times f. So that's expression to convert frequency to our angular velocity in radians per second. Now, I want to talk about one more. Often we're talking about how many RPM, right? RPM means how many revolutions per minute. That's kind of like a frequency as well. Then how do we find this relationship? Okay. We know, for example, if I want to change a revolution per minute, we're going to change to omega, which means one revolution is going to be equals again 2 pi radians. And then we can change this minute to seconds. 1 minute is 60 seconds. In that situation, again, you change your RPM to how many radians per second. So the way we do it is going to be RPM. It's going to be RPM times 2 pi over 60. That's going to be our convention vector. Then that will give us omega, give us radians per second. So that's something else, okay? The difference between this one and this newly derived one is this 60, because this is frequencies per second and here is per minute. That's why that's the only difference there. All right, now I want you to go back to this original power transmission equation. We're talking about power transmission. P is equal to torque times omega. If the problem is, so we can actually now write this as omega. We know if it's given frequency, so that's going to be 2 pi f, right? That's going to be another expression, because 2 pi f we're talking about here is equal to omega. Okay. Now, I'm going to look at one more most commonly expressed one, and often we talking about the power, we don't talk about watt. In US, we talking about, for example, your mower. What's the power used to describe the mower power? That's in horsepower, HP, right? So then also the torque, that most commonly used torque is going to be pound-foot. That's the torque often being used. Then omega, the angular velocity, we don't see how many radians per second. Most likely used is RPM. Okay, so if we threw those three things together, so here's a challenge for you to figure out what would be the conversion factor if we stick with those three units: horsepower to describe power, and pound-foot for torque, and RPM to omega. What will that be? So now let's go ahead and try to figure this out. We start with this formula. Power is equal to torque times omega. And so here, torque is going to be equal to power over omega. All right, be aware, this torque, here we're going to use pound-foot, okay? So if we're going to use pound-foot, and then this power here, we're going to use horsepower. Then omega here, we're going to use RPM. I'm going to change my color to talk about the conversion here. One thing we need to know, for this unit to work for US system, power, if we are going to use US system, the base unit for the power will be what? Pound foot per second. Because why? Because pound foot, that's energy. Energy divided by time, that's power. Because energy for US system is force times distance, pound force times foot. Okay? Then for the torque, we're going to use pound foot. Force times moment of arm, and omega being angular velocity is radians per second. Radians has no unit, so basically this equation is satisfied. So in order to do that, what we're going to try to do here is, if I were to use horsepower instead of pound foot per second, okay? So we're going to look at the conversion. 1 horsepower is 550. This is an easy number to remember. Pound foot per second. Okay, so in that case, we change the horsepower to pound foot per second, our standard unit. That's good. Now RPM. We don't want an RPM to describe our angular velocity. We want a radians per second. So remember, 1 revolution, it's right actually here, right? If we know RPM, we're going to change to omega. We already did that. It's going to be 2 pi over 60, because 1 revolution going to give us 2 pi, and 1 minute is going to give us 60 seconds. So that's our conversion factor right there. So knowing that, this will give us the pound foot per second for our power unit. Write down, right? And for omega, then we get our radians per second. That's very nice also. Then our torque will have to be pound foot. So that will make our dimension unit work. So now then we're gonna thinking about it. If we do of that, what will be, I'm gonna write down the horsepower in red, RPM in red. Now I want you to figure out, do a little quick math here to figure out what's all that's going to be equal to. What's 550 divided by 2 pi over 60? So putting it to your calculator, it's worth to do it one time. So pause for a second to calculate 550 divided by 2 pi over 60. Okay, I hope you already get the number in there. So it's 5252. That's again very easy number to remember. That's very helpful number. So what's this indicate is, in a situation they told you about horsepower, that's our power unit. You don't need to change that to pound foot per second. If they tell you RPM, you don't need to change to radians per second. You're just going to directly use those numbers in horsepower and RPM, and then times this 5252, this number here, then you're going to get your desirable unit for the torque in pound foot. All right, so this is very helpful. You will see an example on that, maybe in your homework and maybe in web work or FE exam. So 5252, here we go. All right, that's all for power transmission. I'll see you on the next one. Bye.